Hello and welcome to a quick video where we will be discussing integer data types in Q. Firstly, what is an integer? Integers are positive or negative whole numbers with no associated decimal or fractional component. Q has three integer data types. This table summarizes the main characteristics of each of the integer data types. Here, the number and the character columns are unique values to identify and cast to these types, and we will come across these in other videos. We will discuss the null and infinity values in an upcoming slide. The short data type is a 16-bit or 2-byte integer value. In Q, a short integer can be defined and identified with a H character suffix. For example, 17H is the short integer 17. Short values can range from -2 to the power of 15 up until 2 to the power of 15 minus 1. The int data type is a 32-bit or 4-byte integer value. In Q, an int can be identified with a trailing I character suffix. For example, 17I is the int 17. Int values can range from -2 to the power of 31 up until 2 to the power of 31 minus 1. Finally, the long data type is a 64-bit or 8-byte integer value. In Q, a long integer can be identified with the J character suffix, but the suffix may be omitted. For example, 17J, or just 17 without any character suffix, is the long integer 17. Long values can range from -2 to the power of 63 up until 2 to the power of 63 minus 1. The reason we can omit the J character suffix from a long integer value is because the long integer data type is the default integer type since Q version 3.0. Integer type numbers will only be a short or an int if the H or I character suffix respectively are appended to the number. For example, 10H is the short integer 10, 10I is the int 10, and 10 or 10J both define the long integer 10. Let's now discuss how Q handles the concept of infinity with respect to integer values. Positive infinity is represented by the largest value that can be stored in the data type, and negative infinity is represented by the second smallest value that can be stored in the data type. Why Q uses the second smallest value for negative infinity will be clear in the next slide. This table shows the representations and the literal values of the infinities for the three integer types. Infinity for the short data type is represented by 0WH and is equal to the short value of 32,767. Infinity for the int data type is represented by 0WI and is equal to the int value of 2,147,483,647. And infinity for the long data type is represented by 0W, or you can have 0WJ, and is equal to the long value of 9,362,372,854,775,807. Note that the negative infinity values are the same with a minus sign prefixed to each value. Q handles the concept of null by representing it with the smallest value that can be stored in the data type. This table shows the representations and literal values of null for the three integer data types. Null for the short data type is represented by 0nh. Null for the int data type is represented by 0ni and is equal to the int value of -0wi minus 1. Remember that minus 0wi is negative infinity. Null for the long data type is represented by 0n and is equal to the long value of -0w minus 1. You might have noticed that I did not show the literal value of 0nh as minus 0wh minus 1 in the table. This is due to a property of shorts that I will discuss next, but just know that you can still think of 0nh as being negative 0wh minus 1. So the property that I mentioned in the previous slide is that a short will be converted to an int when any arithmetic operations are performed, apart from divide, which always results in a float. For example, 10h plus 1h equals 11i, 10h minus 1h equals 9i, and 10h multiplied by 1h equals 10i. Although I'm not 100% sure why this is done, it is not so much of an issue since shorts are rarely used by Q developers other than for identifying and casting data types. Also, if a short is desired, then you can simply cast back to short after the operation. Another property to be aware of is that int and long types will wrap their values if they exceed their bounds. So an example here is if you have an infinity, an int value of infinity represented by 0wi, and you plus 1, you'll actually wrap back round and go to the smallest int value, which is 0ni, or the null integer value. And then if you were to plus 2 to the infinity value for an integer, then you would actually wrap around and go to the second smallest, which is negative infinity. And you can see other results, it works in the opposite direction. So if I start at minus infinity and I minus 1, then I'll actually go to null. But if then I started at minus infinity and I minus 2, I would wrap back round and go to the largest int value, which is infinity. And you can see in the second example that a similar thing will happen for longs. So just something to be aware of. That's everything for this video. Thanks for watching, and I will see you in the next one.